Thanks for joining my short presentation on one of our services, the Operator Staffing Study by User-Centered Design Services. My name is Stephen Maddox, and I've been helping operators effectively manage abnormal situations for 15 years now. There are several aspects that affect the operators, and we specialize in teaching and implementing best practices within the following categories: control room design, console design, operator staffing, operator procedures and operator excellence culture, alarm management, high performance HMI, fatigue management, operator training, and management of organizational changes. Today we're going to focus on operator staffing. We have several experts that work on our team. Ian Nemo, our company president, is known for his book on the high performance HMI, but he's most famous for creating and running the ASM Consortium, which is focused on reducing incidents related to human error during abnormal situations. Ian was instrumental in leading the efforts to obtain government funding. He raised $16 million for the consortium. He and several others spent years investigating incidents, which led to the development of best practices in control room design, operator workload analysis, HMI design, and alarm management. Ian has spent the last 40 years helping the industry build a culture around operational excellence. David Lee is our vice president. He is an expert in HMI, alarm management, and safety. Harlan Graft was a plant manager for ConocoPhillips. He helped redefine our methodology for analyzing operator staffing and workload. Harry Williams is an expert in operator training and helps a lot of our customers develop and expand on their operator training. Research has identified that today's operators are slow to detect, diagnose, and respond to abnormal situations, and detection often only takes place after an alarm has enunciated. Abnormal situations can be very costly, so we rely on operators to intervene and quickly manage the situation. However, operators have a hard time deciphering the exact cause of an upset. Data overload and a ticking time clock do nothing to help the situation. Human error is a leading cause to mechanical failures, environmental excursions, downtime, and safety-related incidents. Operator workload analysis should be assessed based on equipment, interaction, and automation to ensure a balanced workload for safe operations. ASM and ISA best practices should always be implemented. The operator workload study is a tool that allows a client to measure the operator workload to identify where job duties are unequal and should be reorganized, consolidated, or new duties assigned. It also identifies management systems that are not meeting best practices. Something that makes us unique in our methodology is the operator interviews. Ian has a knack for getting the operators to open up. He's on their side, and the information they provide is a key component to the study. On the right, you can see a list of companies we performed our staffing studies for, and we've done this very recently within the last year. We apply a three-part model to develop a score for each operator position. Each position is compared across the other positions within the facility, and then compared against the industry average and the pace setters. We also analyze the management support systems to determine how well the facility is positioned to support the operators. Our three-part model consists of the equipment complexity, the interaction, and the automation and DCS system. The equipment complexity score. The operator is impacted by the type of equipment being operated. A highly dynamic reaction process is much more difficult to operate than a slow-moving tank farm. To account for these variations, we use our equipment model and assign a score to each piece of equipment. A simple pump or heat exchanger has a low score, while compressors have high scores. The score also takes into consideration the additional maintenance and failure potential of the equipment. Interaction complexity score. The operator workload is significantly influenced by upstream and downstream areas. An area that has upstream and downstream tankage with stable utilities is much easier to operate than one that has hot feeds, sends products downstream, and is highly dependent on dynamic utility systems. To measure the complexity of a given area, we consider the number and type of interactions within the facility, interactions with external suppliers, and interaction with customers. We assign a score to each significant input, output, and utility for each area. This score is weighted to account for how dynamic the stream is and how significant an impact it has on the operation of that area. Automation complexity. The control system's complexity has a significant impact on the operator workload. Poor control system performance can come from poor alarm management practices, poor console graphic design, navigation, and poor tagging conventions.
advanced control that does not promote stability during upsets, poor control valve maintenance, poor PID control or loop tuning, nonlinear control with linear algorithms, a badly trained operator making poor moves. To determine the impact on the operator workload, we create KPIs and calculate a score using the following data: controller changes or operator moves, number of standing alarms, alarms per minute during upsets, steady state alarms, chattering alarms, the number of operator changes, the number of controls that are not in their optimum mode, the total number of control loops, and the total number of configured I/O.
We also go through an interview process where we interview management, supervisors, engineers, and operators. This process helps us to identify other areas that impact operator performance. Operators are interviewed at their console stations. We confirm the data we've collected and ask for insight on anything we might have missed. We use this time to understand the culture and operating practices and procedures. The input received during the interview is compared against today's best practices to determine how the site is positioned to support the operator workload. Both the numeric scores and interview data is compiled into the final report.
All three scores from the equipment, interaction, and DCS automation assessments are combined to arrive at a numerical rating for each position. 11 operator positions are shown below. A few things that stand out in this graph. The dark red bar shows you the workload of the industry pace setter. They've implemented best practices. The green bar shows you the industry average, allowing you to compare your operators against others within your industry. The dark blue bar shows your average score. This allows you to easily compare your operator's workload against the pace setters and the industry average.
We also look at how the alarm system contributes to the operator workload. This case shows how an alarm improvement project could reduce the workload affecting 5 operator positions. We also look at the number of operator moves for each operator position. In this particular case, we identified that 114 of the 237 loops have been in manual more than 50% of the time just in the last 30 days. The final report will contain several case examples where we show you how the workload would change if you consolidated positions, improved alarm activations, or added or removed an operator position. Once we receive the OK to start, a full data collection plan will be provided to you. It consists of alarm and operator event data, as well as P&IDs for equipment counts or PFDs, and organization charts. We can help with the data collection activities. Next, we schedule times for all the interviews. It is important that these are scheduled in advance in order to be proficient with our time on site. Once we have the data, 2 of our operator project managers will arrive on site, usually for 1 week, depending on the size of the facility. We will perform the interviews based on the predefined schedule to determine additional duties and tasks beyond those normally accounted for in the model. Then we go off-site to develop the final report. It is highly recommended that we schedule a return site visit to deliver and review the final report with your team. We highly recommend that you keep your report updated. If you change the equipment, the process, the DCS, or the staff, request a report update. Based on the type of change, we'll update the model and send you the effects so that you can avoid risking failures or breakdowns due to the changes. Beauregard went through a large reorganization project. One objective was to combine several control rooms into one. They went from 12 operators down to 7. This had a huge impact on staffing costs and automation costs, but they had to make sure safety was not compromised. They hired us to conduct a Management of Organizational Change Assessment, MOOC. Ian trained 20 Beauregard employees during the assessment so that they could follow the model at all of their plants whenever they're going to make a staffing change. Below you can see a picture of the final control room and the HMI that was designed by UCDS. Thank you very much for attending this presentation. Hope to talk to you soon. You can visit our website at www.mycontrolroom.com.